Welcome back to Cypress Academy PSoC 6 101. In the next few videos, I will show you the basic building blocks to create our BLE controlled robotic arm. This will include a UART terminal interface, PWMs to control the servo motors, easy I2C dashboard interface, a digital logic-based kill switch, capacitive sensing controls, and an advanced technique for RTOS debugging called tracealyzer. As I go through these videos, I will first create a bare metal implementation so you can understand the basics for each of the peripheral functions. And then we'll integrate those functions with an RTOS into the BLE controlled robotic arm project. Let's start with the UART interface to a PC terminal client. The UART interface is great as a rudimentary debug interface when developing an application like this. It can also be used as a basic communication peripheral for other system ICs in your project. First, we will add a new project to our previously used workspace. Let's call it Basic UART. As with our other projects, let's drag and drop the UART component onto the schematic. Double-click again to edit. Let's call it UART. All the other settings look good, so just click OK. Double-click on the pins file under the design-wide resources and assign the RX and TX to P50 and P51. On the back of the PSoC 6 BLE Pioneer board, you can actually see the silk screen, which tells you where all of the IOs on this kit are. This is a nice quick reference for you as you build these projects. So everybody likes to use printf. How do you make printf work in PSoC 6? To do that, I need to retarget standard out to the UART interface. Cypress has built a library that will allow you to retarget. We call that library Retarget IO. To include this library into your project, open the build settings, click on PDL, scroll down and click on the checkbox right next to Retarget IO. Now let's run the generate application. Once that's done, you'll see a file called standardio_user.h that's been generated in the shared files folder for you. This is where you configure the UART that you want to use for standard out and standard in to point to. Scroll down to the first few lines of code. We need to #include project.h so we can reference the appropriate UART below. Next, go to #define IO_standardout_UART and tell it which hardware block is being used for the output. In other words, which SCB you are using. PSoC Creator generates a macro for you that you can use so you don't need to figure out which specific hardware block. In this case, the name is UART_HW, which is your instance name of the UART appended with the _HW. Now do the same for the #define IO_standardin_UART. And now our Retarget IO library is set up. We're going to control the UART with the Cortex M4. So let's open up the main_cm4.c. Start the UART using the API call. Standard in is typically buffered, which means the characters you type go into a buffer, but you don't know they're there until you read. I want to turn that off for this program so we can handle each character as it comes in. To do this, we'll write a line of code. Set vbuff standard in null _IO nbf 0. This means there will be no buffering on standard in. For this basic project, I just want to echo the characters that the PSoC 6 receives back to the terminal client. So let's create a character variable called C. Let's show that printf works. Amazingly, it does. Let's print out started UART in this example project. Now, in our main loop, let's get a character, see if anything was returned, and then print that character out to the screen. And that's it. Now time to build, program, and test it. First, I'm going to open the Windows Device Manager to see which COM port the KitProg is attached to. You can see which COM port it's attached to under the Ports tab. It will be labeled KitProg 2 USB UART. Now open up your favorite terminal client and attach it to the correct COM port at 115.200 baud 8N1. I know the baud rate and 8N1 settings because they're in the component configuration dialog that we saw earlier. Now, in the terminal client, whatever I type is echoed back to me on the screen. In this case, I type PSoC 6 is awesome, and I totally agree with that. In the next video, I'm going to show you how to take this UART starter project and move it into an RTOS, and then take the first steps in building the main robot arm controller project. You can post your comments and questions in our PSoC 6 community, or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. Thank you.